Now we move from understanding Besu to planning a real solution. We'll start with the business problem, clarify stakeholders and trust, and turn those insights into requirements that shape architecture, smart contracts, and enterprise operations. You've already built the foundation: what Besu is, how networks are structured, how contracts and applications are built, and how governance and security work. Next, we'll connect those pieces into a complete delivery lifecycle, beginning with requirements. Before configuring Besu nodes or writing contracts, define the business use case. Ask what outcome must improve, who needs to coordinate, what data must be shared, and where trust or auditability is missing. This keeps blockchain from becoming an expensive technology choice in search of a problem. Once the use case is validated, requirements become clearer, and decisions about consensus, permissioning, privacy, governance, security, and deployment can be designed around real business value. A strong blockchain use case starts with a coordination problem, not with the technology. Look for processes that cross organizational boundaries, where parties need a shared record but should not give one participant full control. Blockchain is more compelling when trust is limited, auditability matters, and history must be tamper-evident. If everyone already trusts one central database, use that instead. Also, test readiness. Governance, integrations, and participant commitment often determine success. Besu fits best when multiple organizations need to share trusted records while still controlling who participates. Examples include tracking asset ownership, proving where goods moved, reconciling payments between companies, or recording approvals in a regulated process. In these cases, Besu provides Ethereum-compatible smart contracts, permissioned access, and an audit trail participants can verify without relying on one central operator. In a regulated supply chain, every handoff matters. A batch may be created, shipped, inspected, received, and sometimes recalled. With Besu, each participant can write agreed events to a shared permissioned ledger, creating a tamper-evident history across organizations. The key design challenge is privacy. Regulators may need transparency, while partners still protect volumes, pricing, and business relationships. Once the use case is clear, anchor the project in a business outcome. What problem are we solving, and what value proves it worked? Translate that outcome into workflows the blockchain must support or reference. Define measurable success, such as faster dispute resolution or broader traceability. Just as important, name what is excluded, assumed, dependent on, or constrained. This turns ambition into a controlled minimum viable solution and protects the team from scope creep later. Next, identify the people and organizations around the network before designing permissions or smart contracts. A company may submit transactions while a different team runs its node. Regulators might observe records without validating blocks. Auditors may need read access, but not operational control. This separation defines accountability, onboarding rules, eligibility, and change approvals early, so the Besu network reflects real business responsibilities instead of only technical infrastructure. Focus on where trust breaks down today. Maybe two companies maintain different records, or one party has information the other cannot verify. Keep trusted internal processes inside each organization. Move only the shared coordination points to Besu: events, state changes, and audit evidence everyone needs to agree on. Then decide which actions need signatures, cryptographic proof, or immutable history. The goal is not to decentralize everything. It is to make cross-party truth independently verifiable. Shared ledger does not mean shared everything. Start by classifying each data element: public to the network, restricted, confidential, regulated, or off-chain only. Then define who can read it, who can write it, and who is responsible for retention. For on-chain design, choose the minimum exposure needed: full data, a hash, a reference, metadata, or a proof. These choices drive permissioning, private transactions, and encryption, while keeping business transparency compatible with legal privacy. Functional requirements turn the use case into precise system behavior. For Besu, this means defining the actions users can perform, the smart contract logic behind them, and the rules that make each transaction valid. Be explicit about roles, permissions, approvals, status changes, and exceptions. Also capture integrations with ERP, identity, monitoring, or databases. A good requirement is testable. For example, only certified logistics providers can submit shipment handoff events. Non-functional requirements define the operating commitments. It is not enough to say the system works. You need measurable targets. How many transactions per second? What peak load looks like? How quickly users get confirmation? And how much downtime is acceptable? These targets drive design choices such as consensus mechanism, node capacity, redundancy, monitoring, backup, and incident response. If they are vague, teams discover limits in production, where fixes are slower, riskier, and more expensive. In enterprise Besu projects, compliance and security cannot be added at the end. They shape the design from day one. Start by defining what evidence auditors will need: event logs, signer identity, timestamps, and transaction traceability. Then map the regulations, data residency rules, and retention periods that apply. Finally, make identity, permissioning, key management, node security, API access, smart contracts, and operational controls explicit. Clear requirements make governance enforceable, not aspirational. Captured requirements create value only when they become buildable work. For Besu, each requirement should drive an architecture decision, such as consensus, network topology, permissioning, or privacy. Functional needs become smart contract features, APIs, and user workflows. Non-functional needs become infrastructure, monitoring, security, and operations tasks. The key is traceability. Every backlog item should point back to the business, regulatory, or security requirement it satisfies, with clear validation criteria. Use case definition turns business goals into buildable Besu designs. Look for multi-party shared state, trust gaps, and audit needs. Then map stakeholders, privacy, ownership, and requirements across security, compliance, performance, and operations. These decisions create traceability into architecture, network topology, deployment, smart contracts, and production readiness.